Good morning, everyone. Let us start this session. So in this session, we will solve the problem on the equilibrium of beams. So in the last lecture, we have seen the types of beams. So this is the first problem where one beam ABCD is given and it is supported by two supports, one at point A and second at point D. Okay. So support given at point A, it is the hinge support. So we have seen the types of support. So there are three types of support. One is a hinge. Then second is the roller. And third is the fixed support. Okay. So hinge support, it has two reactions like this. So VA and HA. Then roller support, it has only one reaction. So this is the reaction RA, RB or RC. And for the fixed support, we have three reactions. One is a vertical reaction, then horizontal reaction, and there is a moment, which is the MA. So this is for the fixed support. So now here, if you observe the point A, then at point A, it is the hinge support, and at point D, so this is the roller support. Okay. So we have seen how to draw the free body diagram for hinge, roller, and the fixed support. So here you can see. So suppose this is one beam, and if you have the hinge support like this, suppose this point is A. Okay. Then its free body diagram, it will be like this. Then at point A, we have to show two reactions. One is VA and second reaction will be HA. Okay. So initially you can assume the reaction HA to be on the positive X side. Okay. So this is for the hinge support. Then we have the roller support. So suppose we have the beam and at a point there is a roller support like this. Okay. Then we will draw the free body diagram like this, and at this point show the reaction which is perpendicular to this surface. Right now the surface is exactly horizontal, so this reaction will be exactly perpendicular to the given beam. Okay, so suppose this reaction is RA. So by referring this free body diagram, we will draw the free body diagram for the given beam. Okay, so at point A, so first draw the beam as it is. Okay, this is point A, B, then we have C, and this is the roller support. So this is a point D. Just assume this point as a E. Okay. Then in the free body diagram, show the external forces as it is. So we will show 8 kilonewton at point B and this 8 kilonewton at point C as it is. Okay, and there is one moment couple given which is 20 kilonewton meter. Okay, so show this couple as it is at this point. So this is 20 kilonewton meter. Then at point A, it is the hinge support. So we will show two reactions. So this is the vertical reaction, which is a VA. And at this point, we have horizontal reaction, which is a HA. So right now we are assuming HA to be on the positive X side. Okay. Then at the point D, it is the roller support. So if you draw the reaction at this point, then this reaction will be exactly vertical. Okay. And it is perpendicular to this line. So this is the reaction RD. Okay, so these are the reactions at point A and at point D. Now here you can observe one uniformly distributed load is given. Okay, so we have seen two types of loading, that is a distributed loading. One is a uniformly distributed and second is the uniformly varying load. So for the uniformly distributed load, suppose we have one beam which is having the length L, and on this beam we have the UDL like this. This is the uniformly distributed load, and this load, it is having the intensity W Newton per meter. Okay, so in the free body diagram, we need to convert that distributed load into point load. So the point load due to UDL, it acts exactly at the center of the total span. So this is the L by 2, and its magnitude, it is given by this equation. This intensity W into the span of the beam or span of the UDL, which is a L. Okay, and unit will be Newton. So this is the point load due to UDL. So apply the same formula for the given beam. So here D to E, it is the UDL. So we need to convert that into point load. So this is the point load. Just take this as F, and it is equal to intensity is 15. So actually it is in kilonewton. Okay, into its span, that is a D to E distance. This is 1 meter. Okay, so F is equal to 15 kilonewton. Now this point where the load will be acting, so it is at distance 0.5, that is at half distance. Okay, so here we have converted this UDL into corresponding point load. Okay, so this is your complete free body diagram. Okay, so in the free body diagram, first we will draw the beam ABCDE as it is. Then at the hinge point, we will show two reactions, VA and HA. At the roller point, show the one reaction, which is a RD. Then these external forces, we will show as it is. Okay, at point B, at point C. Then this moment, which is a 20 kilonewton meter. And then convert this UDL of 15 kilonewton per meter into corresponding point load, which is a 15 kilonewton. Okay, so here if you observe total unknowns HA, VA, and the reaction RD. Okay, so we have three unknowns. So to solve this, we need three equations. So we will use three equations. One is summation fx0, then summation fy0, and summation of moment. This is equal to 0. Okay, so these are the conditions of equilibrium. So here, by using the conditions of equilibrium, we can find out the unknown reactions HA, VA, and the RD. Okay, now here we will use summation of moment first. Okay, so from this equation, we can find out the reaction RD. So while using this equation, we need to select the moment point. So first I will use summation of moment 0. Now how to decide the moment point for this equation? So observe the point where two unknowns are meeting. Okay, so at the point A, we have two unknowns. One is a VA and HA. Okay, so we will select point A as a moment point. So take moment by all the forces about the point A. This is equal to 0. Now write this equation. So we will start from HA. So that moment is 0 because HA is passing through point A. Then VA, this moment is also 0 because it is passing through the same point. Now take the 8 kilonewton. So 8 into. So what is the perpendicular distance for 8 kilonewton? So distance AB, which is equal to 1 meter. So this is the perpendicular distance. So 8 into 1. Now we need to decide the direction for this moment. So this 8 kilonewton, it will rotate the beam ABCD in the clockwise direction. So this is negative. Next, we have this 20 kilonewton meter. So this is the separate moment given. Okay, so it is not the force. So do not multiply this moment by the distance. Okay, just add or subtract this moment by observing the direction. So right now this moment, it is a clockwise, so it is negative, and this is 20 kilonewton meter as it is. Next, again we have 8 kilonewton and distance AC. So here you can see 1 meter, 0.25 plus 0.75. So total AC is 2 meter. So force is 8, distance is 2 meter. And this moment, it is again clockwise. So it is negative. Next, we have the reaction RD, which is the unknown. So reaction RD and its moment will be reaction RD is at distance D. So total distance A to D, this is 3 meter. And moment by reaction RD, this is anti-clockwise about the point A. Okay, so this is positive. Next, we have the point load due to UDL, which is 15 kilonewton into distance of this point load from the point A. So this is equal to, so up to point D, it is a 3 meter plus 0.5. So this is 3.5. And this moment, it is again clockwise. Okay. So this force 15 kilonewton will try to rotate the complete beam ABCD in the clockwise direction. So this is negative and this is equal to 0. So this is your complete moment equation about the point A. Now from this equation, just find out the reaction RD. Okay. Okay, so you will get minus 96.5. Okay, and this is equal to RD into 3. So RD into 3 minus 96.5. So this is equal to 0. So shift this on the right hand side. So reaction RD is equal to 96.5 divided by 3. So the reaction RD is equal to 32.16 kilonewton. Okay. So this is the one unknown. Now for remaining two unknowns, one is HA and VA, use remaining two conditions. Summation Fx0 and summation Fy0. So summation Fx, this is equal to 0. Now for summation Fx, just observe the given free body diagram. Okay. So we have HE on the positive side then there is no second force in the x direction. Okay, so only HA for summation fx. So this is equal to 0. So this is the second unknown. Okay, and then use summation fy is equal to 0. So for summation fy 0. Okay, so consider all the forces in the y direction. So starting from VA, so VA is positive. Then we have 8 kilonewton in the negative y direction, so minus 8. Then again minus 8. Next we have reaction RD, so plus RD. After that we have 15 kilonewton, so minus 15, and this is equal to 0. Do not add this 20 kilonewton meter because this is the moment. So this value only consider in the summation of moment equation. Okay, so this is your complete summation Fy. Now put the value of RD, which is 32.16. Okay, so here it is 32.16, and now get the value of V. So VA, this is 1.16. Sorry, VA plus 1.16. This is equal to 0. Okay, and from this we will get the value, which is VA. This is equal to minus 1.16 kilonewton. Okay, so what is meaning VA is minus? So actually VA, this value is 1.16 kilonewton. It is in the negative x, so negative y direction. Okay, so actually we assume VA in the positive x y direction, but from the answer, the correct direction is in the downward direction. Okay. Okay, so in this way you can find out the unknown reactions. One is the reaction RD, HA, and the V. Okay, so now refer the second problem. So here one beam AB, it is loaded as shown in figure. Okay, and we have to determine the reactions at point A and at point B. So first step, to solve the problem on the equilibrium, we should draw the free body diagram. Okay, so for the free body diagram, just draw the beam AB. Okay, next step is the point A, it is the hinge support, and the point B, this is the roller support. So at point A, we will show two reactions. So this is the VA and the horizontal reaction HA. Then at point B, there is only one reaction. So at this point, the reaction will be perpendicular to this surface. Okay. Now this surface is horizontal, so reaction will be exactly vertical. So this is the reaction RB. Now next step is we have to convert this load, which is the UDL, and this load, which is the combination of UDL and UVL, into point load. Okay, so just make one construction. Here 200 Newton per meter. This is the intensity of this UDL. Okay, so just draw the horizontal line like this. Okay, so this horizontal line, it will show that the complete intensity is 200 Newton meter. So this is 200 Newton per meter. Okay, so this complete is nothing but the UDL over the span AB. And here we have the triangle, which is the uniformly varying load, which is the UVL. Okay, so for the UVL, this maximum intensity, okay, total here value given 400 Newton meter. That is from this point up to this point. Okay, so the remaining value, this is equal to 400 minus 200. So this is equal to 200 Newton per meter. So here we have divided the given load into two types of load. One is a UDL having the intensity 200, and second is the UVL. So our next step is we need to convert that into point. So first consider the UDL. So UDL is distributed over the span AB, total span. And this intensity, this is equal to 200 Newton per meter. So to convert this into point load, so this is the point load due to UDL. Okay, this value, this is equal to 1 by 2, sorry, not 1 by 2, 200 into total span AB, which is 4 plus 3. So this is 7. So this is 1400 Newton. Okay, and this point load due to UDL, it acts at half distance. So total is 7. So this is 3.5 and this is 3.5. Okay. So show this point load on the original free body diagram. Okay. So this is your AB. Total span is 7. So this is the point load due to UDL. So just assume this as F1. So this is equal to 200 into 7. So this is 1400 Newton. Okay. And it will act at distance 3.5. So it is at half distance. Next, we have the UVL. Okay. So just consider that triangle. So this triangle, so that triangle is here like this. And this is the distributed load. Sorry, varying load. So this side, this is 400 minus 200. So this is 200 Newton per meter. Okay. So up to this point, its distance is given. So this is 3 meter. Okay. So whenever we draw the free body diagram for the varying load, we will convert this varying load into point load. So just I will show that point load. So this is the point load. Okay. This value of the point load, this is equal to F2, and it is equal to the 1 by 2 load intensity, which is a 200 Newton per meter. Use the formula, which is the area of triangle, 1 by 2 base into height. Okay. So this is the height into base is 3. Okay. So this is 600 divided by 2. So this is 300 Newton. Okay. 300 Newton only. So this is F2, which is 300 Newton. And it will act at a point which is L by 3 from this 90 degree. Okay. So from this 90 degree, this distance is L by 3. So L is nothing but 3, this total span. Okay. So this is L by 3, and that is equal to, this is 3 by 3. So this is 1 meter. And from this point, the distance will be, so this is 2L by 3. Okay. So always remember this total length is L. So 2L by 3 means 2 into 3 upon 3. So this is 2 meter. So this is equal to 2 meter. Okay. So just consider this point as a point C. Okay. So this is the point C. And this is the point load because of uniformly varying load, which is the F2. And this is equal to 300 Newton. Okay. Its distance from point B, this is 1 meter, which is the L by 3. And from the point C, so this distance, this is equal to 2L by 3. So it is a 2 meter. Okay. Now here, from this point load F1, the distance of point C, so this distance A to C is total 4 meter. This is 3.5. So this is equal to 0.5 meter. Okay. So this total distance, this is 4 meter. Okay. So this is your complete free body diagram. Okay. So here first we have converted the UDL into point load F1. After that, we have converted this uniformly varying load into point load F2. So you can refer this conversion. Okay. So I have already explained this in the last lecture. Okay. So now next step is we should use the conditions of equilibrium. So from the condition of equilibrium, we can find out the unknowns. So first identify the unknowns. First is HA, then VA. These are the unknown at the hinge support. And then the reaction RB, which is at the roller support. Okay. So first use summation of moment. This is equal to 0. So by using this equation, you can find out the unknown RB. So take the moment where you can cancel out the moment by the remaining two unknowns. So we should select point A as a moment point. So right here, summation of moment by all the forces in the system about point A is equal to 0. So A is the moment point. Now take the moment by all the forces. So here, moment by HA and moment by VA directly 0 about the point A, because these two forces, they are passing through the point A only. Next, consider the F1, which is 1400 Newton meter, into perpendicular distance of this force from the point A, it is 3.5. And this moment, so if you observe this force, it will rotate the given beam in the clockwise direction about the point A. So this is negative. Next, we have F2, which is the point load due to UVL, uniformly varying load, which is 300 into the perpendicular distance of this force is 3.5, 4 plus 2 meter. Okay, that is a 6 meter. Again, this moment, this is clockwise about the point A. So this is negative. And next we have the unknown reaction RP into the distance of B from the point A. It is 4 plus 3. So it is a 7 meter. And this moment by the reaction RB will be anti-clockwise. Okay, so this force RB will rotate the rod AB or the beam AB in the anti-clockwise direction. So it is positive, and this is equal to 0. From this, calculate the reaction RB. So this is minus 6,700 plus RB into 7, and this is equal to 0. Okay, so from this, reaction RB is equal to 6,700 upon 7. So this is 957.40. And the unit is Newton. Okay. Now answer for RB is positive. That means our assumed direction for RB is correct. So it is in the positive y direction. Okay. So after this, use summation fx0. So for summation fx, observe all x forces. Okay, or the x component of forces. So only we have HA. So this is HA. It is equal to 0. So second reaction is 0. And next use summation Fy equal to 0. So for summation Fy, start from Va, which is a positive. Okay, we have assumed to be positive. Then F1, which is 1400, negative. Next F2 is negative, so minus 300, and plus reaction RB. This is equal to 0. Okay, now put the value of reaction RB, which is 957.14, and get the value of reaction Va. So you will get the equation like this: Va minus 742.86 this is equal to 0. So Va is equal to 742.86 Newton. Okay, so Va is also positive. So our assumed direction for Va correct. Okay. So these are the unknowns. One is HA, which is 0. Then Va 742 and RB is 957 in the positive y direction. Okay. So in this way, you can find out the unknown, that is unknown reactions. Okay. by using the conditions of equilibrium. Okay, so this is the next problem. So this is from the university question paper, and it was asked for 8 marks. So what is given? If the support reaction at A for the beam shown is 0, then find the force P and the support reactions at point B. Okay. So one condition here it is given. The support reaction at the point A is 0. Okay. So if you observe the given beam, then at point A, it is the hinge support. So this is the hinge support, and B is the roller support. Okay. So your first step when you solve any problem on the equilibrium or equilibrium of beam or any other problem, then you should draw the free body diagram. So draw free body diagram. So draw the beam AB, sorry, ADBEF as it is. Okay, then at point A, we have hinge support. So it will have two reactions. One is a VA and second is the reaction HA. Next, at point B, it is the roller support. So it has only one reaction, which is the reaction RB. So that reaction is perpendicular to this surface. So it is a vertical. So this is reaction RB. Next, show the point loads as it is. This is 10 kilonewton, and here we have the P value. So 10 kilonewton is acting at this point, which is the point C. Then we have force P. It is acting at E point. And at the point C, there is one moment or couple moment given. So its value is 16 and unit is kilonewton meter. Okay. And for span D to B, so here we have the point D. So for this span, there is a uniformly varying load. And the intensity, that is the maximum intensity, is 24 kilonewton meter. So here I will draw the span dB only. So here we have point D and this is the point B. Okay. For this span, we have this uniformly varying load. Like this. Okay. This side, this is equal to 24 kilonewton meter. This is called as the intensity for the UVL. And distance dB, this is 5 meter. So whenever we draw the free body diagram for UDL or the UVL, we need to convert that into point load. So in the free body diagram, so this is span dB and this is the point load. So this magnitude of this point load, F is equal to 1 by 2. Height is nothing but this intensity, which is a 24, into its span is 5 meter. Okay. So this is equal to 60 Newton, 60 kilonewton. Okay, so this is the free body diagram for this uniformly varying load. Now, this force is acting at distance L by 3 from the point B or from this 90 degree. Okay. So total L is 5 meter. So this is equal to 5 by 3. And this distance, this is equal to 2L by 3. So it is 2 into 5 upon 3. Okay. So this 5 by 3, this is equal to, it is 1.66. And this is 3.33. Okay, so in this free body diagram, that point load, because of this uniformly varying load, so it will be at this point, this magnitude is equal to F, which is 60 kilonewton. And from this point up to distance point B, its distance is 1.66. And from this point, which is the point D, this distance, this is equal to 3.33. Okay. So now we have converted the varying load into point load. So this is your complete free body diagram. Okay. And now next step is we can use the conditions of equilibrium. Okay. So for the condition of equilibrium, so if you observe here, then total unknowns VA, HA, reaction RB, and the force P. Okay. So out of these 4 unknowns, 2 unknowns are directly given. So just observe this line. Support reaction at point A 0. Okay. So meaning is HA 0 and VA 0. These are the 2 support reactions at point A. So from the given information, HA is equal to 0 and VA, this is equal to 0. Okay. So remaining unknowns are, we have to just find out the force P, and second is the reaction RB. So we can use the conditions of equilibrium. We cannot use summation Fx is equal to 0. Okay. So what is the reason? So if you use this Fx is equal to 0, then other than HA, there is no force in the X direction. Okay. So now use remaining 2 unknowns, 2 conditions of equilibrium. One is summation of moment, this is 0. And second, summation of Fy, this is equal to 0. So first use summation of moment 0. Okay, so you can select any point to find out this moment. So whenever we use summation of moment 0, then select the point where you can cancel the moment by remaining unknown. Okay. So right now we have 2 unknowns, force P and the reaction RB. So I will select the point B as a moment point so that I can cancel the reaction RB and I can calculate the unknown value P directly. So write the equation summation of moment by all the forces about point B, this is equal to 0. Okay, so now start from VA and HA. So actually these reactions are 0. Okay, so their moment will be 0. So need not to consider this moment VA and HA. After that, we have 10 kilonewton. So this is 10 into distance of this point with respect to B. Okay, so just observe this original diagram. C to D, this is equal to 2 plus 5, which is a 7. And the direction of moment, so the 10 kilonewton is acting at point C and B is the moment point. Okay, so this moment by the 10 kilonewton, it will be anti-clockwise about the point B. So just observe. This is the point B, which is the moment point. This is the 10 kilonewton and this is 7 meter. Okay, so this force will try to rotate the complete beam in the anti-clockwise direction about the point B. So that moment is positive. Next, this is the individual moment couple, which is 16 kilonewton meter. Okay, and it is given in the clockwise direction. So consider this is minus 16. Okay, so for the individual moment couple, just add or subtract that moment. Do not multiply that moment by the distance. Okay, so it is minus 16 because it is clockwise. Next, we have this point load 60 kilonewton, and its perpendicular distance from point B, it is 1.66. Okay, again this moment is anti-clockwise. So this is point B, and this is the force, which is 60, and this is 1.66. So this moment, it will try to rotate in the anti-clockwise direction. So it is positive. Moment by reaction RB, it is 0 because RB is passing through the point B only. Okay. Next, force P into distance of force P from the point B. So it is given as a 2 meter. And this moment is clockwise. Force P will rotate this complete beam in the clockwise direction about the point B. So just observe here. This is your point B, and this is the force P. So this moment, this is clockwise. So it is negative, and this is equal to 0. Okay. So from this equation, get the value of the force P. So force P, this is 76.8. Okay. This is kilonewton. And this answer is positive. That means this direction is correct. Force P, it is in the downward direction only. Okay, so we have calculated one. No? Next is we should find out the reaction RB. Okay, so now second equation is summation Fy0. So for summation Fy, Vi is already 0. We have 10 kilonewton in the negative y direction, so minus 10. Then this minus 60. Then this plus RB. And this minus P. This is equal to 0. Okay. So reaction RB, this is unknown, and we know the P value. So your equation will be, this is minus 10 minus 60 plus RB and minus P, which is minus 76.8. This is 0. Okay. So get the value of reaction RB. So reaction RB is equal to 146.8 kilonewton. Okay, that means reaction RB is acting in the positive y direction only. Okay, now refer the next problem. So this is also from the university question paper, and it was asked for 8 marks. So question is, find the support reactions of the beam loaded as shown in the figure. So here beam given, which is A, B, C, D. Okay. So your first step will be draw the free body diagram. So for the free body diagram, just draw the beam ABCD. Okay, so this is the given beam ABC. Next, the point A, it is the hinge support. So at the point A, we will have two reactions. One is a VA and second is the HA. The point B, this is the, sorry, point A is the roller support. So at the point A, only one reaction, which is the RA. Point B, this is the hinge support. So at point B, we have two reactions. One is VB and second is the horizontal reaction like this, which is the HB. Then this point load 20 kilonewton, we will show as it is at the point D. So this is the 20 kilonewton and it is acting at an angle 40° with respect to x-axis. Okay. Then at point B, there is one couple which is 10 kilonewton meter. So show that couple as it is. So this is the couple value, which is 10 kilonewton meter. Then this is the UVL, which is 4 kilonewton meter. So this is the maximum intensity. Total span is A to B, which is 6 meter. Okay. So I will show the conversion. So this is the AB span and this is the UVL. This is 4 kilonewton per meter. AB, this is equal to 6 meter. So we will convert this into point load. So this is the point load because of this uniformly varying load, and this is equal to 1/2 its intensity, that is a height, into base is 6. Okay, so this is equal to 12 kilonewton, and it will act at distance from this 90°. Distance is L/3. So L is 6. This is 6/3, and this is 2L/3. So 2 into 6 upon 3. Okay, so 6/3. This is 2 meter, and this is equal to 4 meter. So this is the conversion of uniformly varying load into the point load. Okay. So show this in the original free body diagram. So this is equal to 12 kilonewton from point A. Its distance, this is equal to 2 meter, and from point B, this is equal to 4 meter. Okay, so this is your complete free body diagram. Now next is resolve this 20 because it is inclined. Okay, so whenever you resolve the force, resolve at this point. Okay, that is a point of contact with the given beam ABC. So this is the X component and this is the Y component. Okay, so X component here, this is 20, this is angle 40°, and this is adjacent. So it is 20 cos 40, and this is 20 sin 40. Okay, and after that, use the conditions of equilibrium. So by using conditions of equilibrium, use the first condition as summation moment, this is equal to 0. Now just observe the free body diagram. Okay, at the point B, we have maximum unknowns. One is HB and second is the VB. Okay, so we should take the moment point as a B. So take moment point B. So this is your moment equation. Summation of moment by all the forces about B is equal to 0. Now take the moment by all the forces about the point B. So I will start from RA. So RA into what is perpendicular distance? So distance of point A from point B. it is given directly 6 meter. This moment it is anti-clockwise. So just observe here. Suppose this is your point B and this is reaction RA. This total distance is 6 meter. So this force will rotate this beam AB in this direction, that is in the clockwise direction. So it is negative. Next we have 12. So moment by 12 is equal to 12 into this distance. Okay. So this distance is 4 meter and this moment it is anti-clockwise. So it is positive. So we can observe here, this is point B and this is the force which is at 12. So that moment will be like this. So it is anti-clockwise. Next we have HB. So that moment is 0. VB, the moment will be 0 because both these forces passing through the point B. Then there is a couple which is 10 kilonewton meter. Okay, it is not 0. Okay, so couple given which is 10 and it is clockwise, so it is minus. Okay, minus 10. After that we have two components, 20 cos 40, 20 sin 40. So consider first 20 cos 40. So moment by 20 cos 40. So here we have the point B and this is the point D and this is the X component which is 20 cos 40. We need to take the moment of this component about the point B. So what is the perpendicular distance? So just extend the line of action. From point B, just draw the perpendicular. So this is your perpendicular distance. Okay. And that distance, it is given as a 2 meter. That is a distance DC. And this moment, it will be anti-clockwise. This force will try to rotate the complete beam ABCD in the anti-clockwise direction. So your moment equation will be 20 cos 40 into distance is 2 meter. So this distance, it is the same perpendicular distance. Okay. And moment is anti-clockwise. So it is positive. Next we have 20 sin 40. So this is point B. This is the point D. And here we have the component, which is 20 sin 40. Now this moment, so this will become the perpendicular distance. And it is given as 2 meter. And this moment is also anti-clockwise. Okay, this force will try to rotate the given beam in the anti-clockwise direction. So it is positive 20 sin 40 into distance is 2 meters. So here 2 meter distance is given. And this is equal to 0. So we have considered all the forces. Okay, and the individual moment, which is 10, and it is negative because it is clockwise given. From this equation, find out the reaction RA. So this reaction RA is equal to 15.72 kilonewton. Okay. And after that, use summation Fx0 and summation Fy0. So for summation Fx0, observe the X forces. So one, we have HB on the positive X side. Next, we have this component, which is minus 20 cos 40. Okay, only two forces. and this is equal to 0. Do not consider this moment. Okay. So HB is equal to plus 20 cos 40. So this is 15.32. So this is the reaction HB and it is a positive. So it is towards positive X direction and our assumed direction is correct. Okay. After that, use summation Fy0. So for summation Fy, consider all Y component. So first we have reaction Ra in the positive Y direction. So here Ra, our answer is positive. So our assumed direction is correct. So this is Ra, then minus 12, this force. After that, plus HB. Then we have Y component, which is a plus 20 sine 40. This is equal to 0. So put the value of, sorry, we have not considered the VB. It's not HB. This is VB. Okay. So reaction Ra is 15.72. Put this value and get reaction VB. So VB, this is minus 5 kilonewton. Okay. Our assumed direction of VB is positive Y direction, that is upward, but our answer is negative. So we can write this equation as VB is equal to 5 and it is acting in the negative Y direction. Okay. So this is the correct direction for the VB. Okay. So in this way, you can find out the unknown values. At point A, we have reaction Ra, and at point B, we have the reaction VB, HB.